Welcome, 7th grade. Today we do volume of prisms and cylinders. This is probably one of the easier ones that we'll do for this section, and it literally is just following the instructions we give, and it's going to be 2 steps, and then you're done. Identify the figures described. Now, finding the volume of prisms and cylinders is not too bad. It's literally doing 2 steps, and we'll show you how to do that. But you do need to remember how to find the area of a circle. Pi r squared. Area of a rectangle. 3 times 7, 21. Area of a triangle. 3 times 7 divided by 2, that would be 10.5. You must be able to remember how to do all of these. So, pi r squared, length times width times width divided by 2. If you can remember those, this isn't too bad. Volume. Any 3-dimensional figure can be filled completely with congruent, same, cubes, and parts of cubes. The volume of a 3-dimensional figure is the number of cubes it can hold. Each cube represents a unit of measure called a cubic unit. So, to find the volume of a rectangular prism, you can count cubes or multiply the lengths of the edges. So if we see a box that is 4 centimeters long, 3 centimeters wide, and 1 centimeter tall, we want to know how many 1 centimeter by 1 centimeter cubes will go in this. We can do that by placing the cubes inside of there, or we can do that by math. Well, if we have 4 times 3, that's going to give us 12 times the height of 1. You can see we have 12 cubes that go into this. The main thing we're going to do is we're going to need to find our faces and our bases for this project. So, 4 centimeters times 3 centimeters, that's the area of a base. Whenever you get the area of the base, you take it times the height, and that will give you the volume. So we're going to write that equation out here in just a second. All right? For the volume of a prism, area of base times the height of the figure. So, you can see this equation right here. B stands for the area of the base. H stands for the height. Okay? The important thing, find the area, find the bases, then find their area, then multiply it times their height. Now we look at this figure right here. We want to look for the 2 items that are the same. So 2 that are the same. I look here, I see 4 rectangles, but I see this end has a square, this end has a square. Those are same. Those are the bases. So we find the area for one of these square bases. They're 4 by 4. So I take 4 times 4. That gives me the area of the base, which is 16. Well, the height of the figure, now I know that seems like that should go up and down, but the height is the distance between the bases. Base, oh, the distance between the bases is 12. So if you want to replace height with distance between the bases, that's fine. So we would take 4 times 12, or in this case we did the 16, so 16 times 12. You can do your math off to the side. $192, and since we're doing area, it would be feet squared. And that'll be your answer. Area of the base times the height, which is the distance between the bases. It's important to remember, height is the distance between the bases. Let's see what they put up here. Use the formula. B stands for area of base. H stands for height or the distance between the bases. Hopefully I've said it enough you realize it's important. So, to find the area of the base, we took 4 times 4. Oh, that gets us 16 for one of those squares. Then, we substitute in 16 for the area of the base, 12 the height or the distance between the bases. We do that multiplication, and we get 192, and they'll put the unit with the next one. Feet, oh, excuse me, it's volume, not area. Feet cubed, because we took 1, 2, and 3 feet, so we have feet cubed for volume. Feet cubed. Now here we need to find the areas of the bases, but first we have to know the bases. I see a triangle, and I see a triangle back here that's exactly like it. Those are my bases. So how do I find the area of my base? I take length times height, okay? 4 times 3, but I have to divide that by 2 since it is a triangle, right? Because that is our formula. 12 divided by 2, that will be 6. Now, whatever this was, we took times the height or the distance between the bases. So from one base to the other base was 6. We do that multiplication. Didn't do anything here. 6 times 6, we have 36 centimeters cubed because we multiplied 3 centimeters. All right. So those are items that we do have. Let's go ahead and see what they put in. Use the formula, area of the base times height or distance between the two bases. All right. 1/2 times 3 times 4, all right, times 6, or equals 6. Then we 6 times our height of 6, and we get our answer. Okay. Let's look at this one. Why don't you take a chance to pause this, see if you can do it. All right, now that you've tried it out on your own, hopefully, I see a square back here, or up here, and a square back here. Those are my two bases. So I need to know, I find the area of the base. So 3 times 3 will give me my area of the base, which is 9. Okay? Now I need to find the height, or that distance between the bases. From one square to the other, it's 8 inches. So I multiply that by 8, and I get 72 inches cubed. Okay? The most important part is finding which ones are the bases. Then you find the area for those, then you move on. Okay, we look at this. 9 times 8, multiply, get the 72, and we're ready to go. Let's find this one again. Take a chance, take a pause, find it on your own. All right, now that you've tried it out, I see a triangle down here and a triangle up here. Those are the same, so I know that those are the bases. How do I find the area for a triangle? Well, height times length, and I divide by 2. Okay? So 9 divided by 2 is 4.5. That's the area of that triangle. Now I take the area of the base, which is what I found, and I take it times the height. That distance between the bases is the height. So take that times the 16. All right, 4.5 times 16, 30, that's 3 up here, 24, 27, 5, 4, 720, have to move my decimal 1, so 72, and it should be inches cubed. Okay. Let's check and see what they put. All right, area of base times height or distance between them. There's your triangle. They did get the 4.5 like I did. Then they put that 4.5 in for B. Height is 16, and we get 72. And some of you may notice we had half the area but twice the length, so it got the same answer as the last one. Something to think about. All right, now, any unit of measure with an exponent of 3 is a cubic unit. For example, cubic centimeters means cubic centimeter, and inches to the third means cubic inch. Now we work on finding cylinders, not harder. Notice, same process. Area of base times height. We just have to remember how to find the area of a circle. Pi r squared. R squared means radius times radius, not just adding the two together, not multiplying by 2, but radius times radius. Some of you have been messing that up. So we look here. Circle on top. I know I got a circle on bottom. So I need to find the volume of this cylinder. Oh, I have the radius. 5 squared times 3.14. So that means 25 times 3.14. All right, that will get me my area. Whatever that answer is, then I take it times the height. The height over here from top to bottom is 4.2. And since my phone is recording, I can't just spit it into Siri and have her give me an answer. We'll get our answer. Let's see what they put. Take a last chance at mine. Use the formula. The radius of the cylinder is 5 and the height is 4.2. Substitute in 3.14 times 5 squared, there's your radius, times 4.2. When we do the math of multiplying all those out, please remember you have to square this first and then multiply. So it'd be 25 times 4.2 times 3.14. You get 329.7 as your volume. And don't forget our meters cubed. Okay. This one, I know there's just been one example, but take a chance on it. Can you find the base? All right. Hey, wonderful. I've got my radius. So it would really help me if you would write, oh, my radius, that's 7 squared times 3.14, because that's what we're going to use for pi, times the height, the area between, or the distance between the bases, that's 3.8. One thing you need to remember when I'm doing this calculation, I have to follow PEMDAS or PEMDAS. I have to do order of operations. Exponents comes first, so it'd be 49 times 3.14 times 3.8. That should have been up here, times. All right? And when you do that multiplication then, you'll get your answer. Let's see how we did. We put those numbers in here. We substitute them in. 3.14 times 7 squared times 3.8. Remember, 7 squared you have to do first. Order of operations. Multiply. You get 584.668. And they're going to put the unit on there. Notice they rounded to the tenths place. If you do, great, fine, wonderful. If you don't, this answer is completely fine. Now, find the volume of the composite figure. They throw a lot at us right away. Don't freak out. Hopefully, you see a triangular prism and a rectangular prism. So I've got to look at just my triangle. I know that that's 6 there. So the area of the base would be 6 times 4 divided by 2. Okay? The height of the whole figure is 6. So, excuse me, that's 24. And divided by 2, 12 times 6, that makes for 72. And that's for one of my two figures. For the other one, I see a rectangle that's the same size as a rectangle back there. 4 times 6 times my height, my distance between is 12. Just like up here, the distance between is 6. So 12 is what I put in here. 4 times 6, that's 24 times 12. I do 24 times 12. 8, 4. All right, 4, 2. That's 288 for that big part on the bottom. So I have the volume for that and the volume for this. Now, hopefully you see, if I have two volumes, I need to add them together to get the total. 360 feet cubed. Break it down into smaller parts that we see, recognize, and understand. Let's go ahead and see what they put down so you can see their pretty handwriting instead of my sloppy handwriting. Remember, you can call me at any time. Volume of a composite figure, volume of one prism plus volume of triangular prism. All right? We need to find each of those. Okay? This for the base, for that one right here. 4 times 6 times 12. Area of the base times the height. Area of the base times the height. We do all that math. We come up with, hey, those numbers look familiar. 360 feet cubed. Now we just changed it a little bit, okay? So, hopefully you can step out and try this. They talk about using pi, but I don't see a need for it. All right? 5 feet here, 5 feet here. That means this one is 5 feet. So, the area for my top one, I got to find the area of the base. Triangle is base, triangle is base. Oh, good. 4 times 5 divided by 2, and I'll take that times the height or the distance between the two bases. All right, that's 6. Now some of you may be asking, can you simplify? Yes, that will work. All right, so 4 times 5 is 20. Divided by 2, that's 10. Times 6. Oh, why am I putting a line there? So 60 for this triangular part. Now we were going to add all that to the area for our bottom shape. Do you see that rectangle, a 4 by 5, 4 by 5? Those are the bases. 4 times 5 is your 20. Times the height of 10. So that's 20 times 10. I see 20 times 10. Have to keep my addition sign between, That would be 200. And you get an answer of 260 feet cubed. All right. Break them down into 2 smaller parts and do them. You can watch this video many times. It makes me feel very good, like I did this for a good reason. If you don't watch it at all, well, you won't hear that comment. All right. So we've got them. You're going to see the same numbers I had. There's the 4 times the 5 times the 10 for that bottom figure. And the 4 times the 5 divided by 2, or multiplied by a half, same thing, for the top figure, times the height of 6. And when they do all their calculations, they do come up with the same answer. Woohoo! All right, try it out. Call me if you need help. It's open. Parents, I've put the numbers out there on multiple things. If you can't find it, you're always welcome to call the school office and then check out and get the number and call me.